Hello, everyone, and welcome back. Today, we are going to be talking about the distance formula and how to use it. This is a very important formula that consistently comes up in high school geometry, so let's dive in. All right, so to find the distance between 2 points, x1, y1, and x2, y2, we use this formula, where the distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. So in a way, we can think of this in a similar light to Pythagoras' theorem. In fact, the distance formula was derived from Pythagoras' theorem, so if it looks similar, that is the reason why, right? This one here, x2 minus x1 squared, this represents the one of the distances squared of one of our legs of our, hypothetical right angle triangle. And this represents the other leg squared. And to find the distance, right, the shortest distance, we're finding between those 2 points, we're finding the hypotenuse, right? So in a way, this is the same as Pythagoras' theorem, but it's just kind of switched so that it's easier when we have coordinate points to plug those in. So I'm going to give an example here. It says find the distance between 3 comma 6 and 9 comma negative 2. So to do that, we're going to first label our points as x1, which point is 1, which point is 2, and this is arbitrary. You can choose whichever one you'd like for this. I'm just going to choose that the first one is x1, y1, and the second one is x2, y2. And now I'm going to plug in my values. So the distance, or d, is equal to the square root of x2 minus x1. So that's going to be 9 minus 3, since 9 is my x2 value and 3 is my x1 value. And we're going to square that. And then here we're going to have plus y2 minus y1. So negative 2 minus 6 squared. Now keep in mind, if we did put things in the other order, we actually would still get the same answer in the end because we're about to square it anyway. So there you go. We would get the same answer even if we switch the order. That said, we do have to switch the order for both, right? Not just one. Okay. So now let's try the next step. Next, I'm going to figure out what's in our bracket. So what is it that we're squaring? Well, 9 minus 3 is 6. So we have 6 squared. And then we have negative 2 minus 6 squared, which is negative 8 squared. So therefore, we have 6 squared is 36. And then negative 8 squared is 64, right? Keep in mind, if we multiply, whether we're squaring something positive or negative, we always end up with a positive value, or 0 in the case that it's 0 squared. But in general, we're going to end up with a positive value. And here's why. Because negative 8 times itself, negative 8 times negative 8, well, we're multiplying a negative number by itself. So we're multiplying a negative by a negative, and that gives us a positive. So definitely something to be careful of, that we're always getting only zeros or positives out of our squares. And then if I add this up, I'm going to get square root of 100, and that is equal to 10. So therefore, the distance between these 2 points, 3 comma 6 and 9 negative 2 is 10. Now that said, it won't always work out this nicely. Sometimes we will end up just getting a square root that we'll have to simplify or something like that. But in this case, we got a nice round number. Whenever we are able to simplify a square root further, whether it's because it's a perfect square or because it has a perfect square as one of its factors, then we absolutely should. All right, let's do a second example for distance formula. It says find the distance between negative 2, 5 and negative 8, 2. So let's do that. So distance is equal to, let's remind ourselves in general, x2 minus x1 squared plus y2 minus y1 squared. And now I'm going to label my points as x1, x2, y1, y2, and so on. So this can be x1, y1, x2, y2. Okay, so let's start with what is x2? Well, x2 is negative 8. And then we have minus y1, which is -2. So it's going to be minus -2. So don't forget that we have the minus sign originally because that's part of the equation. And then we have another minus sign because x1 itself is a negative number. So it's 8 minus -2 squared. And then for this one, it's y2 minus y1 squared. So y2 is 2 minus y1, which is 5 squared. And then we're going to simplify that. So -8 minus -2. Well, keep in mind, if we have minus a negative number, we really add. So this is really -8 plus 2, which is -6. So we're going to get -6 squared. And then 2 minus 5, well, that's -3. So -3 squared. And then we're going to get positive 36, right? Because whenever we square a negative number, we still get a positive number back out. Because when we multiply two negatives, it gives us a positive. So positive 36, and then plus positive 9. And that's going to be equal to the square root of 45. Now, we can actually simplify this a little bit more, even though it's not a perfect square. The way to know if we can simplify or not is we have to ask ourselves if there are any factors in 45 that are perfect squares, right? So what's the first perfect square other than 1, right? Because one isn't going to count here. It's 4. Does 4 go into 45 evenly? No, it doesn't. Okay, what about 9? 9 is the next perfect square because 9 is 3 squared. Does 9 go into 45? Yes, it does. So therefore, I'm going to change this to root 9 times root 5 because 9 times 5 is equal to 45. So root 9 times root 5 is going to be equal to the square root of 45. And now I can simplify the square root 9 because what is square root 9? It is 3. So this is equal to 3 root 5. Now 5 is a prime number, and so 5 is not actually going to be able to be simplified further. The root 5 won't be. But we were able to switch from root 45 to something a bit simpler. So therefore, the distance, in this case, the distance between the 2 points, so between -2, 5 and -8, 2, and -8, 2 is 3 square root 5. And there we go. All right, well, great work with that today, everyone, and I will see everybody next day for our next topic. Bye, everyone.